We're going to be looking at the cross product. So what is the cross product? So if we're given two vectors, u and v in R3, all right, the cross product of u and v are denoted u cross v like this, sort of u times v, is the vector orthogonal to both u and v, right, in the direction determined by the right-hand rule. This is a lot. All right. So let's look at two vectors. So we have, assuming we have the vector v here, and then let's have, so v on the y-axis and u on the x-axis. All right. So if we have this vector that is orthogonal to both of them, then this is going to be u cross v. Now, and remember, we're going by the right-hand rule. So we talked about the right-hand rule. If we go by the right-hand rule, then this, the one up this vector right here on the positive z-axis is u cross v. So that means that the vector coming down here also orthogonal to both of them is going to be v cross u. So automatically we can see that u cross v is actually the same thing, or v cross u is equal to negative u cross v. So this is the properties, one of the properties of the cross product, that u cross v is equal to negative v cross u. All right. In order to be able to work with a cross product, we need to understand what the determinant is. So the cross product, that's what we've defined. Now, we need to have an idea of the determinant. I'm sure some of you guys have done this, but let's just review the determinant. Okay, the determinant of a square matrix, I'm going to explain. A square matrix A is denoted det A like that, or kind of absolute value of A, and is defined as follows. It's defined and is defined as follows. So how about this? Let's say a square 2 by 2 matrix. 2 by 2 matrix, square 2 by 2 matrix. And I'll explain what I mean. So assuming if A is equal to A, B, C, D. So this is what a matrix is. In fact, this is a 2 by 2 matrix. So assume A, B, C, D are numbers, scalars, right? It's 2 by 2 because it has 2 rows and 2 columns, right? So if A is this 2 by 2 matrix, then the determinant of A is equal to the same thing as the absolute value of A, like that, and is computed as A times B, A times D minus B times C. So is AD minus BC. Now, if A is 3 by 3 instead of 2 by 2, then we have a different computation. So well, let's not worry about it. Let's not put 2 by 2 here, since we're gonna also do 3 by 3. So if A is A, B, C, D, E, F, G, H, I, then the determinant of A is gonna be, I'm gonna write it this way, then determinant of A is that A, B, C, D, E, F, G, H, I. I here is just a scalar. It's not a complex number. It's not the imaginary number. So now look, I'm going to write A times the determinant of E, F, H, I, right? So I take A, I ignore its row and its column, I multiply by the determinant of this 2 by 2 matrix, and then minus B, I take B now, I ignore its row and its column, I multiply it by this matrix DGFI times I guess DFGI, same thing, right? And then plus, I do the same thing to C multiplied by DEGH, the magnitude, sorry, the determinant of DEGH, all right? So you notice it goes like this, plus, minus, plus. Okay. So A times the determinant of the remaining elements when you cross out the row and the column of A, minus B times the determinant of the matrix comprising the remaining elements when you cross out the row and the column of B, and then plus C times the determinant of the 2 by 2 matrix comprising the rows and comprising the elements remaining when you cross out the row and the column of C. All right. So if you do this, then this is the same thing as A times EI minus FH minus B times DI minus FG plus C times DH minus EG. All right. So, but I think it's quite easier to remember this format, this one. I think it's better to just remember this. All right. So there are different ways of evaluating the cross product, but we have a theorem which we're not going to prove, a theorem that tells us how to do it using determinants. So we want to evaluate the cross product. So assuming we let U be equal to U1, U2, U3, and V equals V1, V2, V3. Remember, we can also write it like this: U is equal to U1I plus u2j plus u3k. All right. And then v is equal to v1i plus v2j plus v3k. I'm kind of abusing notations here. All the I you see here is quite different from the I you see here, and none of them is the complex number I, right? So just note that. All right, so we want to find the cross product of u and v. U cross v is actually the determinant of, let's start with the second row. We write u1, u2, u3. The third row, v1, v2, v3. And then the first row, we have I, j, k. I, j, k. Remember I, j, k, the unit component vectors. So this will be, if we find the determinant, we have I times u1, I times u2, u3, v2, v3, right? Minus j times u1, u3, v1, v3. All right, plus k times u1, u2, v1, v2. Okay, so this is just going to be I times u2, v3 minus u2, v2. Okay, minus j times u2, v3 minus u3, j, u1, I think it's u1, v3, making a mistake, making a mess, u1, v3, minus u3, v1, okay, plus k times u1, v2 minus u2, v1. All right, so that's how we calculate the cross product. So with this, let's do an example. Let's do some examples. So let u equals 1, 3, 4, and v equals 2, 7, negative 5. Let's find u cross v. U cross v is the determinant of I, j, k, 1, 3, 4 here, 2, 7, negative 5. So we get our I, and then we have 3 times negative 5 minus 4 times 7, right? Plus, no, not plus, minus. Minus j, 1 times negative 5 minus 4 times 2, plus k, 1 times 7 minus 3 times 2. Okay, so this is going to be equal to I, negative 15 minus 28, I think, minus j, negative 5 minus 8, plus k, 7 minus 6. So this should give us negative 43i plus 13k plus 13j plus 1k. Or we can write it like this, negative 43 13, 1. Okay. So I want you to find U, V cross U. What is V cross U? All right, try that. There are two ways of doing it. There's a very easy way. And then same method as in A. Like so I want you to try both ways. Look for the answer using the very easy way. Actually straight, like it doesn't require any work. And then verify your answer by doing the same thing we did in A. Something similar to what we did in A, okay? Now, let's try another problem. I want you to find, so I want you to try this yourself, or maybe not. Let's do it together. Find a vector orthogonal to the plane that passes through, a plane that passes through the point P, we love our P, P1, 4, 6, Q, Q, -2, 5, -1, and R, 1, -1, 1. All right. So we have this plane. It has all these points on them. All right. So you have the points P, you have the point Q, you have the point R. I'm just assuming that these are the locations, and it doesn't matter. So think about this. We can create two vectors on this plane. So we think of the vector now that is perpendicular to these two vectors, right? The vector perpendicular to these two vectors is going to be perpendicular to the plane also. It's going to be orthogonal to the plane. Orthogonal means perpendicular in 3D, okay? So it's going to be orthogonal to the plane. So all we're looking for is this vector. Let's call it V, okay? So the vector V is going to be equal to the vector PQ cross PR. All right, PQ cross PR. Okay, so PQ is -3. Verify this. I want you to verify this. It's -3, 1, -7 cross 0, -5, -5. That's what I got. PR, PQ, PR. Okay. All right. Before I proceed, I want to point out that you can also do, in this particular problem, you can also do PR cross PQ. So this would be -V. -V will be PR cross PQ. Okay? And that will suffice. And even if you also do RQ cross RP, that works also, right? Any two vectors you can create with those 3 points, its orthogonal projection, it's the vector orthogonal to two of them is going to be orthogonal to the plane itself. All right, so V is a cross. So if you do this, you get I, j, k. You have -3, 1, -7. They have 0, -5, -5. I did this. I want you to verify my answer. I got -40i minus 15j plus 15k. Okay. Okay. Let's proceed. All right. Next thing we're going to look at involving the cross product is the geometry of the cross product. Of the cross product. Geometry of the cross product. All right. I'm just going to state a few things here. If you have a parallelogram, you can use the cross product to calculate its area. Area of a parallelogram. How about this? Let's create our parallelogram first, and then let's see if it makes sense what I'm going to be talking about. So I have this parallelogram. This is my V. This is my U, right? If I complete it, something like that. This is the angle theta between U and V. We can show, but we're not going to do that. We're not going to prove in this class, but we can prove that the area of this parallelogram is actually the magnitude of the vector U cross V, which is the magnitude of U times the magnitude of V and its sine theta. Listen, when we had the dot product, we know that whenever we try to compute the dot product, we're expecting a scalar, like a real number, a scalar. But when we do the cross product, we're expecting a vector. So U cross V is always going to be a vector. But here we're taking its magnitude, right? So this, and that is magnitude. Or, well, you know what? I'm just going to put a little, a little mag here. Magnitude. Why am I putting it? Because we've already used that notation for determinant. So we are abusing notations left and right in this section. But math, you can't avoid abusing notations. Sometimes you run out of notations. You have to start reusing what you've used before. Okay. Now, if that's the case, if theta is equal to 0, or theta equals 180 degrees, then U cross V is equal to 0. So in other words, when we have two parallel vectors, their cross product is going to be the 0 vector. Mind you, this is the 0 vector. Remember that when we have two orthogonal vectors, their dot product is 0. So two orthogonal vectors, dot product is 0. Two parallel vectors, cross product is a 0 vector. Okay? All right, I'm going to leave you with something to do. Try by yourself. Okay. So let's call this example 3. Example 3. So let's consider our friend P, 2, 3, 4. Let's consider Q, 3, 2, 0. And let's consider O, the origin, 0, 0, 0. The first question here, I want you to find the area. Find the area of the parallelogram with vertices O, P, and Q. All right? So I want you to find it. And then I want you to find the area of the triangle whose vertices are O, P, and Q. Parallelogram, and triangle. All right. My hint is that the triangle is going to be half the area of the parallelogram, the area of the triangle. So that's all I'm going to tell you. Okay. I will see you in the next video and in class also.